everybody. This is an introduction and support for calculating earthquake epicenters. I'm going to make it as fast as I can, but there are a couple of areas where you may find the circles that you're trying to make in order to determine the epicenter don't exactly meet. So let's take a look and see why that might happen. This is the first page of calculating earthquake epicenters. I'm going to go to the second page because there's some directions. And we're going to take a look very quickly at how you go about doing this. Okay, I switched pages on you. The directions state, and I'm not going to read them word for word, but what essentially it tells you to do is to go to these graphs, and these represent information that came in to the seismic station, for example, at Akita, Japan. And so what happens is we have our Richter scale. We have our distance scale, and what we're looking at is we're looking for the S waves. Now we know from our studies that the P waves are the primary waves and they arrive first. Here's the P waves. We're not looking at those, we're looking at the S waves. And we want to know how long did it take for them to reach Akita, Japan. On the bottom is the time scale, so this is going to be a little different for everybody. Each vertical line indicates 2 seconds, and so a lot of people have said 70. I actually might say 71. Here's your first little bit of variation. I might say 70, you might say 71, somebody else might almost say 72. I don't think it's 72, it's 70 or 71. I'm going to go with 71. You'll see my calculations are based on 70 because that's the information that most people turn in, and so that's what I've done. We're going to go down now to Busan, South Korea. We're going to go to the second set, and that's about 56. And we're going to go down to the third set from Tokyo, second set, about 44. So we're going to record those in a chart that's found within your paperwork. Okay, so we're going to take this information, and knowing that it took 70 seconds for the S waves to get to Akita, Japan, now we want to figure out, well, how far is that from Akita, Japan? And so they've given us this graph. And so we said it was 70 seconds. So we're going to go over here, and it's just past this mark. So it's 600, 2, 4, 6, 8, 680 kilometers. Okay, let's stop right there. It's a little bit more than 680 kilometers, isn't it? But that's what our information has given us as their example to start. So here's another piece where we're off just a tiny bit. If you wanted to, you could say 685. Yeah, maybe 685. We're going to go with their example. We're going to use 680. So once again, we're off just a little bit in terms of what we're seeing and how we're measuring on paper. Okay, so I looked at one graph and I figured out when the S waves came in. And from Akita, that was 70 seconds. I used my graph to tell me if it was 70 seconds, how far away was it from Akita, Japan. And I came up with this number. It was 680 kilometers away. I'm going to use my map now because I need to know on my map, how do I know where to draw 680 kilometers? Okay, so now I've turned to the page that has the map of the Japan region. I'm just showing a small part in the right corner because I want to use this scale. So I've used my graph, and I know that the epicenter of this particular earthquake is approximately 680 kilometers from Akita, Japan. But how in the world do I know where to draw that on my map? So I use the scale. Here's 0, here's 100 kilometers. We're going to use the kilometer side. Now, the information on the handout says that this distance from 0 to 100 kilometers is 12 millimeters. You will want to use millimeters or centimeters because it actually becomes easier. Here's the thing, whenever anything is printed or photocopied, it doesn't come out exactly 100% the same as the original. It's off by just a little bit. So when I measure 0 to 100 kilometers for my map that I printed out, I get 11.5 millimeters. So measure this for yourself if you can in millimeters. Mine is 11.5. The example given to you in the instructions is 12. But I want my numbers to fit my map, if that makes sense. So here we go. Okay, so I've gathered information on which I can start to make some decisions, and I can start plotting points on a map. So I said on my drawing, I have 11.5 millimeters for every 100 kilometer. Here's my example. From Akita, Japan, the epicenter is 680 kilometers away. This is my conversion to know where to draw that on my map. Every 11.5 millimeters that I go on my map, I've traveled 100 kilometers. I want to travel 680. So if you think of this as mathematically, I'm going to divide 680 by 100, and I'm going to get 6.8, and I'm going to multiply it times 11.5. So this divided by this multiplied times this. And I get 78.2 millimeters. So on my map, I'm going to draw a giant circle because I don't know which direction this is. But I know 78.2 millimeters away from Akita, Japan on my map is that epicenter. Okay, so here's my map. Now here's Akita. I measured out 78.2 millimeters. Now here we go again. How accurately, look at this dot. This dot is at least 1, almost 2 millimeters wide. So where I set my ruler on Akita is going to make a difference. And I'm going to go out here, 78.2 millimeters. Well, I'm probably going to go to 78, right? And maybe just a smudge more. I'm going to make a dot. Here's what I did because I didn't have a compass at home. I then went from Akita, I came out here, 78.2, I came out here, 78.2, and by freehand, as you can tell, in the blue line labeled 1, I have now made the majority of a circle around Akita on my map, 78.2 millimeters away from Akita. When I do my other calculations, let's go back to that. What I come up with, sorry for the scrolling, from Busan, Korea, I said it was 540 kilometers. I'm going to do the same conversion. I want to convert this to something, a distance I can use on my map. So I do my conversion, I get 62.1 millimeters. From Tokyo, I get the distance, the map distance, as 50.6 millimeters. So I come down here, I do exactly the same thing. I go, okay, where's Busan on my map? Okay, Busan is right here. Once again, that dot itself is 1 to 2 millimeters wide. So I try to set it in the center, and I'm going to go, let me look at my number again, I forgot it, 62.1 millimeters from Busan. So here I go, that's the purple line. I start making my dots, I connect my dots. I know it's got to intersect with the blue line, so I cheated, okay? I didn't do a full circle. Here's my Busan, it's the purple, number 2 line. I do the same thing for Tokyo. Here's Tokyo, and I came up with 50.6 millimeters. So I'm from Tokyo, if I were doing this whole thing, I'd make a big circle around Tokyo, 50.6 millimeters. Okay, now let's revisit this again. How accurate do you think my 50.6 millimeters is? As accurate as I can make it. And my 62.1 millimeters, and wherever I put my ruler is on this dot, and you can see my 3 lines don't ever really cross. Truth be told, if I were to come out here, this is my dot from Akita. My dot from Akita, I probably made a mistake and it should be over here. See how flat my circle is here? And this comes from not having a compass to do this with. My dot from Akita should probably be right about here, because I flattened my circle out. I should have redone it again and given you a nice circle. So you can see these three don't exactly cross. Do I know why? You bet I know why. Because first of all, I'm recopying things. They don't come out exactly the same scale. One of the things that occurred is in this example, I think it should be 71 and not 70. And I think that might have helped my map. You can see that all along the way you have these little discrepancies. How do you measure 78.2 millimeters? So when you're doing this, know that if we were all sitting in the classroom together and we all had our fabulous maps all photocopied from the same photocopier, and we ended up with numbers that we agreed upon every step of the way, and we had a very precise instrument that would allow us to measure, say from Akita, out 78.2 millimeters, we would get to a spot where our three circles would cross or would be very close. The responses we're accepting for this are either Kobe or Osaka, because once again, it's going to depend exactly on your ruler, your kilometers on your map. But we know that someone has gotten near the target epicenter point if they're around Kobe or Osaka. So if you don't match exactly, that's okay. What you're going to want to make sure that you do with your students, though, is you're going to want to go through with the group, maybe give them some of these numbers so that you know that it's getting close. If you have compasses for them, it's going to be a lot better than my flat circle, which is going to be a huge step in the right direction. I hope this helps a little bit. If you're getting things that are wildly different, go back to the data you collected. When did you say the S waves came through? What did you say your scale on your map was? Did you measure from the city correctly and accurately? Are you off by a 0.1, 0.2? All of those things will play a factor. Sorry this is so long, but it just takes a few minutes to go through to finally getting to the epicenter circles.